Hello, sir.
Oh, okay.
Yeah, Anuj, can I have some questions. Can I ask? Start.
Yes. Now can we start with the this is your main first question. Whatever we started with our project initially.
Okay.
Now we'll start with the
So
questions. Okay.
I have some small question regarding on your project. So you said you have worked with 180 nanometer technology, and you said 1.8 voltage as VDD, right?
Yes.
So what is the maximum VDD you can give for that 180 nanometer?
180 man.
Yeah. Like
It's,
maximum voltage,
yeah,
how much you can give supply?
um, I guess it is 3.3 volts. I don't know.
3.3.
I guess I'm not sure exactly.
Okay. So, let's say I am working with some 20 nanometer or 60 nanometer technology. So, what is the supply voltage I can give? Means that need to be similar to 1.8, or it need to be less.
No, sir. It needs to be less, I guess.
Okay. Number
Maybe
wise, that is
point 0.9 volt. Right? Point 0.9
point
volt. 9.
point 0.9. Yeah. Okay, that's fine. Like the relation is important, whether the value is more or less the important point. So can you justify why, like advancing the technology? Okay, advancing technology in the sense reducing the channel length, nanometer. So why the supply voltage is reducing? Do you have any reason?
Uh, what I feel is because due to advancement in technology,
Hmm.
we should make devices which shouldn't take more voltage.
Why?
Like for small voltage only, it should operate. I guess we should not waste energies in something like that.
Energy and all, when we combine voltage and current, only energy will come. With voltage, energy will not come. Let's say I have 100 volt, I have zero current, where I am wasting energy then? Energy will combination of voltage and current in electric domain. Let's say I have 1000 volt, but I am not taking any current, zero. But I can say I am
Yes.
not wasting any energy, right? If I have 100 volts, I will take 1 micro. If I have 2 volt, I will take 10 ampere. Then trade-off will be there, right? So depend load will
Yeah.
decide the current, that is okay. But in terms of energy, what you said, it is called advancing technology. Main reason for advancing technology is the power saving perspective. That is okay, I agree. But why the voltage trade-off is happening with respect to the technology node? There might be some reason, because when we are changing technology, something we are changing in the device. Because of that one,
So
voltage we are
definitely it
reducing.
should be something.
Yeah,
Yeah,
something is there.
something.
Yeah. So try to find out that one. It might be interesting question, because
Yeah, sure.
no one will, everyone will think
And
of work on this one, but no one will think of why we need to reduce voltage, what will happen if we increase voltage. With respect to technology, why voltage is reducing? Some very good reason will be there. Interesting reason. Try to find later, okay? Okay, so we will start with ask the question. So can you draw a low pass filter in the whiteboard? Okay, fine. So, can you draw impulse response of the circuit, like voltage impulse only, right side, voltage impulse of the low pass filter, impulse response.
in voltage input has some rate of the.
Okay.
Mm. So it's like only the final answer.
Yeah, okay, you can go from step by step. I don't want fancy. Just try to
Yeah,
solve intuitively.
yeah,
Go step by step. What
yeah,
is
yeah.
happening? What
Yeah.
exactly going inside circuit? Slowly. No problem.
It's- yeah. Since it is the impulse input, no,
Hmm.
it will be only there at a t is at a zero time.
Okay.
So we can consider two time instances, zero minus and zero plus, and we can try analyzing our circuit in these two parts, and we can try this thing T and V. So um, we can go, we can solve the circuit using these basic equations. So I equal to C dV by dt. And we know that just after this, before t equal to 0, since the capacitor do not have any charge, uh, assuming capacitor do not have any charge. So straight after giving the impulse, no, we can write it as integral I dt. As I have mentioned, we'll consider for time instance as 0 minus, we didn't have anything. So I can write 0 to 0 plus current is some impulse function
Like try
into
to
dt.
solve with less equations, less intuitive. Mostly try to solve using intuitive analysis. Like it is not a just a RNC, it is there. There is nothing to have with max, right? If you
Yeah.
have number of elements, then we need to use max because of references. So your R is there, C is there, and pulse also only at one instant we have. So I think so no need of equations mostly. When I want exact value, you can solve equation, but I want the portfolio, how the waveform is coming exactly. I don't want how much rate it is decreasing, how much it is starting. No need, just the waveform, how it will come, increasing, decreasing, like this, like that. That's all. That is fine. Just a
Yes, sir.
behavior I want.
Yeah. Sure. So right after the circuit P is equal to 0 now, this capacitor will become short as for T equal to 0 plus. So there will be some current flowing in the circuit. So this current will be initially there is no output voltage. You can write it something like this. And so due to this impulsive current, the capacitor voltage should rise suddenly. And next, after this time t is equal to 0 plus, since there is no any input, the capacitor should decrease this in this path only. So since after time t equal to 0, as I have mentioned, the capacitor has some fixed voltage, na?
Hmm.
So it will discharge. So capacitor output waveform can be something like this. It is 0 and there is a sudden jump, and it will again discharge completely.
1 second. 1 second.
Yeah.
Hello. You can continue.
Yeah, so as I have mentioned, so there will be sudden jump in the capacitor voltage, and after t equal to 0, this capacitor should discharge in this resistor, and it
Hmm.
should go to the 0. So if we want this particular voltage, I can give it from this equation.
Okay, fine. That's fine. So at exactly t equal to 0, the cap is shorting. Yeah.
Yeah,
Why? Any reason at t equal to 0? Why it is shorting?
so that because at 0 time, we can say the frequency is infinite frequency is there, and
Hmm.
the impedance of the capacitor is 0. So we can short it to ground. So I said there is no initial voltage across the capacitor, it could be 0. And also here there is no um,
Yeah, okay.
anything,
You're
any extra
saying
circuit, so it is direct
impedance
short.
of cap is 1 by c omega, omega tending to infinite, so it
1
will
by
become
C.
0. So
Infinity is
mathematical
0.
wise, okay, okay. Mathematical wise, okay. Okay, we will get back to you this point later. So, okay, the graph is fine. What you said is correct. And can you draw similar for step response? Voltage step response. Some V voltage.
Yes, sir. So say I give some V volt step input. Similarly again, right after time t is equal to 0, there is finite amount of current only. So capacitor will hold its voltage as 0 only initially. So
Hmm.
as gradually increases,
Hmm.
um, so at infinite times, capacitor will become open circuit.
Okay.
So the output equal to input, so it will charge till that V volt on.
So I have one small doubt here. If we take
Yeah.
impulse and step response at t equal to 0, the frequency component is infinite, tending to infinite. Okay,
Mm.
that is fine. Because of that infinite frequency, cap is shorting. That is also fine.
Yeah.
So when cap is shorting, output is 0 simply.
Zero.
Okay,
Zero.
right, correct. Okay. So at t equal to 0, the circuit response is same. Cap is shorting. T equal to 0. Circuit response is same. Input voltage and output is 0. Okay. But
Mm.
why the responses are coming different in impulse and step response? Even though t equal to 0, the same frequency component I am injecting and the same circuit behavior it is coming. Means simply circuit behavior in the sense cap is shorting, output is seeing ground. At t equal to 0, I am saying.
Mhm.
If you are
Yeah.
saying at t equal to 0, I can say output is seeing 0 in two cases and the frequency component also going infinite. In two dimensions, it is similar, but the response is different here. Why it is coming like that? What is the
Yeah,
main
it
reason
is.
behind these two?
Yeah, it is because of the inputs which we have applied, sir. Step input, yeah, there is no any like after t equal to zero, there is no off something like that, no discharge and all. But due to impulse, na, it is high amount of like voltage. It is around infinity, na, delta of t. We treat it as. So suddenly a high impulse is coming at t equal to zero. So the
Huh?
capacitor should charge. So
No, no, no,
impulse will
no.
be there
See,
at
see,
zero.
see.
Yeah, not.
Capacitor will charge in step and impulse. That is secondary. Capacitor will anyhow charge. What I am asking was at t equal to 0, the response is similar in the circuit. Infinite
Yeah.
frequency is injecting. I am injecting the means it is seeing infinite frequency. That is true. But why the response is not starting from same point? See,
Yeah.
after t equal to 0 plus, we can say that is different. But here response why it is starting in different places. At that point, I have similar conditions.
So one thing is, sir, we generally say the capacitor holds its voltage only when
Hmm.
finite amount of current flows in the circuit, sir. But here for impulse input, no, there is an infinite amount of current. Like we generally say it as some infinity by R, so
No,
it doesn't change. It can
impulse was
change. Uh,
impulse
so high amount of current.
doesn't mean that it is having infinite current, right?
No, no, not infinite current. So it is giving some infinite value at this time, infinite voltage at this
Okay.
time, and its current is by R, so infinite current is flowing. We can assume something like that, and the
Hmm.
capacitor the voltage will change when there is an infinite amount of current in the circuit. We can say it will be same only when finite amount of current flows in the circuit.
So
Here,
as you
for
said,
stepping,
as you said, if you are saying infinite amount of current is flowing, according to C dVc by dt, the capacitor voltage will also become infinite, right? As you say, dVc by dt equal to current. I is going to
uh,
infinite. dVc, delta change in voltage need to become infinite. It's a short duration of time. But you are saying some number is there here. It is not going infinite. Actually, it will not go. When we keep resistor, it will not go infinite. In
no, it's not infinite,
any,
but something like
hmm, but you said infinite
so.
current, but voltage also need to go to infinite, right? As you said.
Yeah, but it is only at that instant, no, sir. Again, after
Yeah,
zero.
at that
So
instant
that's why
only I
we
am.
analyze that two
Yeah,
instant.
at that instant only I am saying the value is not infinite in the graph. I am saying only at that instant. At that instant, it is not infinite value.
Yeah.
You only see you only drawn the this wait. You only drawn the response, right? This is infinite value, no, right?
No, no, sir.
So as you said, you are saying infinite current is going, then definitely voltage need to come.
Yeah.
Let us take ideal case, anyhow the circuit will work. If you take practical case, even though you are giving impulse response, yet short duration of picoseconds are very 10 power minus 20 seconds also, whatever very short duration of time, if you give the infinite current, the circuits will blast. in practical.
Yes.
But even though practically impulse we can generate using these waveforms, we can generate impulse.
Yes.
Because of that, current is going to infinite. We are using resistor here. Always I am using resistor here. But still you are saying the current is
Resistor.
going infinite. Then there is no need of using resistors then here. If you are saying infinite current is
Yeah.
going. You got it, right?
Resistor opposite. Yeah,
Yeah.
got it.
That means you are saying infinite amount of current is going, then what is the use
Yeah.
of using resistor here? You are
Yeah.
breaking the
Yeah.
property of the resistor here.
Yeah.
Yeah, there might be some main difference between the responses there. Because at t equal to 0 only, the situation is getting similar. But what it is happening was, after t equal to 0, something is happening. Just to think about that one. Because of that one, the response is coming different here. Just to think now, 2-3 minutes, just think what is exactly happening here. At t equal to 0, the circuit response is same, but the graphs are coming different for us. As you said, impulse is discharging, step is charging. Anyway, okay, charging and discharging, okay, that is fine. But for different frequency, infinite frequency, same condition, and output is also saying ground. But why the graphs are coming differently? One main observation is there in the two responses. Just to think 2 minutes now. I will give some late there.
Here, what I feel is, sir, in the impulse condition, at t, the ideal property of capacitor is it holds the voltage. Sir. Here,
Hmm.
we can see like this also. So at t equal, comparing the t0 and t equal to 0 plus conditions,
Okay.
at these both cases also it should be same as a capacitor.
Okay.
VC of 0. But in this case, due to this impulse thing, VC at 0 and at 0 plus it is different, sir. So, but whereas comparing to the second case, at 0 and 0 plus the thing is same here. The input is same and
Hmm.
also the response is slowly charging. Here it is
Yes.
not the case.
Yeah, now you
Yes,
got.
so
Yeah.
yeah.
But it is not
So that
100%
is the
perfect
main reason.
answer. That is not 100% perfect answer. But I think you got. You are very close now.
Okay.
Now you got the
So
because of input. Because of input, the response is coming like that. But now, why because of input it is coming?
yeah.
50% you got. Why because of input it is coming? Yet after t0 at one instance, how input is mattering, you got to know. But how? If we able to define how it is coming, then your answer will be 100% perfect. No. Same circuit response only. Don't care about equation. Just see the circuit, what is happening. Something is happening means there is one reason is there. Because of that one, that response is coming like that. So just think one more time, 1 or 2 minutes again, and try to find.
So also one more thing, what I can say from this thing is, at
Hmm.
that time instance, 0 and 0 plus the voltage is decreased, sir. So if voltage is decreased, means this current also will be decreased.
Which response? Impulse or step?
Impulse increase, this 0 and 0 plus.
Okay.
We see that this input is reduced from
Okay. Correct.
some
Correct.
value to it is coming to 0.
Yes.
So similarly, the current equation, which is like V minus, suppose V out by R. Na?
Yes.
Initially, I say, suppose this thing is some 1 by C, I guess. This value
Yes.
will be.
Mm-hmm.
And, at T is equal to 0, my current will be, uh, at T equal to 0,
Huh.
the voltage is 1 by C.
Yeah,
And like
okay.
that. And next to
Mm.
that, minus 1 by RC. Na?
Okay.
So current is reduced, I mean, so discharged part.
Hmm.
Also, the same current in the next thing, it is not like that. No? Again, it
Okay.
will continuously increase.
Okay.
So one thing, this is also one more difference we can say in these two
Yeah, I think
things.
you almost came, but still you are missing some point. So what is the main funda is here? Let us take the impulse response. The response I am saying like this, okay?
Yes.
0 minus.
Mm,
So when at t equal to 0 exactly, the cap will short. It will
mm,
short. So we will see 0. And here, one more thing is, when the impulse is at t equal to 0, here the main important point is, at one particular time, two instances are happening. Charging and discharging starts. This is the main point. At t equal to
Main
0,
point, yeah.
impulse is
Right?
applied, cap is shorted, it will see the whole amount of energy is applied at this point at the time instance at t equal to 0. Here it will see ground. So because of V equal to IR, as you said, the cap will charge first of all. So when the cap will charge, it will rise. And the amount is suppressed by the resistor. So it will charge to some
This
finite
is,
value.
yeah.
Yet immediate at t equal to 0 only, it will start discharge. Why? There is no
This,
force. There is no force.
yeah, this,
That's why it will
um,
discharge. Here what will happen was,
yeah.
initially it will go, it will also same, it will see 0. But
Mm,
if some amount of current is flowing through cap, right? At
this,
equally it is short, it will see ground. Okay, it will see whenever if you apply step response at t equal to 0, cap will see. Not full amount of energy is applied here. Still some force
okay.
is there here. Voltage is still there. T0 plus also.
Voltage is,
So
yes.
cap will short, so it will take 0. Then difference will be there, right? The current is try to go fully here. Let's say if the amount of at that instant, the whole current need to go to cap, it will raise the voltage. But here some voltage is there. The difference will maintain. Let us say if I have already force here, the difference will reduce, right? Earlier there is no difference. The input
No,
itself
no,
have
yeah.
0. So whole energy is transferred.
Mm,
In terms of energy, I'm saying
transfer.
here the difference is reduced because of input I have V voltage.
Yeah, it is
So
continuous.
yeah, it is continuous. When it is trying to charge or discharge, it will charge fully means full amount of energy is gone earlier in the impulse response. Now it also try to go fully, but here some voltage is there, here some voltage is there, difference is there. Difference will be very less, right? So slowly,
Yes.
it will charge slowly. This slow rate because of resistor, it will stop the current. It will go slowly. So
Okay.
when the cap will fully
Sure.
charge, it will develop some voltage till 0 to 5 volt. When the 5 volt it came, 5 difference is 0, then it will stop charging. Here main point is input response is there, right? Because of there is no input after t equal to 0 plus, both states are achieving very quickly. Main point is this one.
Very quickly.
Immediately charging,
Yes.
immediately discharging. Why? Because there is no force to stop that one. Here the force is there. That's so V is the force here.
Yeah.
This so
Mm,
so from here I want to ask one more question.
yeah.
Most of the system they will see impulse response only when they want system behavior. I, impulse response usually they will see what is the impulse response system. Why any need why only they are seeing if I take any system, if I want the response of the system, mostly I will prefer just to see the impulse response. Everyone will say see the impulse response. So from that one we get to know how exactly the system is. Why not step response, ramp response? Why people are only preferring impulse response to know the characteristics of the system? Why not any other response?
Because So if
Hmm?
we do the impulse response and get the output, there won't be any extra pole in the circuit. So.
Okay.
But whereas if you do the unit step and ramp, it will introduce the poles in the circuit.
Hmm. Hmm.
So maybe sometimes some instabilities come maybe somewhere in the circuits.
Yes, yeah,
But
that is
if we
correct.
use the impulse
Yeah.
response, it's Fourier transforms one. So
Yes, correct. See, if you see this graph, right, this is the pure system
yeah,
response. There is no force in the system.
uh, not no
So
force. Yeah,
when we want the system behavior, we will prefer impulse only because impulse is anyhow applying a particular instant of time only, but later on that means it is not forcing the system. After that time, it is not forcing. The system is responding normally with respect to the system
yes, sir.
characteristics or R and C L elements. That's why people will say
Mm-hmm.
impulse response. We can say impulse response is also the natural response of the system.
Yeah,
Yeah, and step response
yes.
remaining are forced responses. We have two responses in the system
Forced
when we think
response.
in
Yes,
control
sir.
system. Natural
Natural
response
and yeah,
and forced response.
it's forced.
So impulse
It's
is a
forced.
natural response. Natural it is there. Nothing is there. So we can analyze the system without any conditions, operating points also. So that's why impulse
Yes,
response is important. Important in the sense that is a natural response of the system. We will get the exact behavior of the system.
yes.
Okay. Anush, can you scroll down the whiteboard? Yeah. So now for the same low pass filter, now I am giving the square wave input. Square wave input. Can you draw the waveform
Okay,
for
sir.
two conditions?
Mm,
Time period is much greater than RC, time constant, and time period much less than RC.
okay, sir.
Just draw the waveforms. This is fine. Anyhow, you know how the charging and discharging are working in the low pass. So directly draw the waveforms. No, it's fine.
First T greater than RC, sir.
Okay.
Suppose this is my input now.
Hmm.
The case when the time period is much greater than RC, no? Our
Hmm.
capacitor has enough time to charge, sir. Because
Hmm.
ideally we say 5 time constants is required for a RC circuit, I mean, for capacitor to reach steady state. No? So we can
Okay.
expect that our output will go to this. Suppose this is some V, it will go to
Okay.
V.
Hmm.
And also it will discharge. It has enough time to discharge also now.
Okay.
Yeah. This is the case for this thing, sir. But
So
when
is
we
this
say this,
is that graph is true for every case or only for some case?
in the sense, I didn't get it exactly.
Let's say one more control parameter is there here we can change duty ratio. I'm saying square wave. I'm
Okay.
not mentioned duty equal to 50%, right? I can take any
Okay.
value.
Okay. Yeah.
So
Yeah.
what you draw on the circuit is at duty equal to
50%.
50. So let's say I will match the time constant according to 99.999% duty I take. So then still the
Uh,
discharging profile will come similar or not?
that depends on the RC values, I guess.
Yeah, okay.
Charging
Okay,
will
fine,
be,
fine. Yeah, okay, fine. Because anyhow, I am taking T is much greater than, we will consider that case.
much greater.
Yeah, much greater than, that
Yeah.
is fine. But one more key point is if we change the duty also, it will remain same. That is an important condition. Why? Because I
Uh,
will consider T is much greater than, then if I change duty also,
Rather
that will
than,
compensate that
uh,
part. There is
uh,
no issue. Okay,
yes,
fine. Then go to
yes.
second case.
Second case, uh, so for my convenience, I am taking this V as some 5 volts. Suppose I am taking it as 5 volt.
Okay.
This is my input. First, as time after time t is equal to 0 plus, no? As I mentioned earlier, the capacitor will be short since there is a uh, I'll name this current. Right? So initially, after time t is equal to 0 plus, our capacitor will be getting charged. No? So our charging current is 5 by R in the first case. So since you have mentioned the time constant is much less than RC, we cannot expect our capacitor output to go till this 5 volts. Na? So suppose we can say capacitor is charged till 1 volt, suppose, for example, in the case 1.
Hmm.
So in the next case, after time t, after time will be 1 by R.
Okay.
I am okay. Suppose since I is mentioned in this direction, discharging current is minus 1 by R. Okay. So
Okay.
again, say since time t is less than RC, we cannot expect our capacitor to discharge fully. Say this capacitor discharged to some 0.8 volt. Just
Okay.
say. Next, in the third cycle, when output is given high again, our charging current will be, since the capacitor hold its voltage, na, it will be
Hmm.
0.8 only after time t is equal to t plus also. So
Okay.
the charging current now will be 5 minus 0.8 by R. So which is
Okay.
4.2 by R.
Hmm.
So this cycle goes on like this now. So we
Hmm.
can say that we can observe that our charging current will be reducing and discharging current will be increasing. So we can
Okay.
observe this kind of trend. Yeah? So maybe this can go till again 1.1 or 2 volts, suppose. And so after some time now, when at steady state, this thing
Okay.
will be happening like this, and it's steady state when both, yeah, the thing when I say the word steady state, it will be like when both charging current and discharging current are same. That is
Hmm.
in this case at V in by 2. So suppose when my input is, I mean, my capacitor is charged till 2.5 volt, na, suppose my charging current will be 2.5 by R, and similarly discharging current will be 2.5 by R in negative direction. So there will be no more this charging and discharging. So the steady state output voltage will be 2.5. So,
Okay. The 2.5, when you take duty, 50.
yes, sir. Duty 50%.
Okay. The 2.5 value is decided by the duty of the square wave, right?
Yes, sir.
Okay. So, so
Because
at,
duty cycle means on time by total time. Na?
yes,
So
correct,
again,
correct,
this
correct.
that will be depending on RCs again.
No, no, no. I am defining duty, right? Input I will define. Why it will decided by RC? I will decide my input. See,
Yeah,
here we already taken the time constant is very, very
yes,
less than RC. Then no, don't care
less
about
than.
RC. Ultimately, time constant, I am saying
Okay.
the condition that is decided by duty as well, right? So duty
Duty as
parameter, the circuit response is similar for any case because I taken time
well.
constant is very, very less than the RC. I mean
Very
time period. So the value we are getting 2.5 or 3, 4, 5, 1, 0, whatever. The response is similar. The stabilizing point is different. That stabilizing point is decided by the duty ratio I have taken. It doesn't mean that if I take 10 duty, 20 duty, the time period will be different. No, for same time period, I will take the
different.
different
Yeah.
duty as well.
Yes.
So, okay,
Yes.
according to if I take duty 50, it is stabilizing to 2.5.
2 point.
Why it is stabilizing at 2.5? How?
Yeah, I can. Yeah, I can say one reason for that. Sir.
Like my question is why it is not stabilizing at 3 or 4?
Yes, sir. Here I am giving some input, na, suppose VI, and I want some V output here. Na.
Okay.
What we are here, what actually at steady state, what happens? Our output should be settled at some value. That settled to some value in the sense the
Yeah, yeah, wait,
capacitor
wait,
at
wait, wait.
steady
One
state the
question. One
capacitor.
question is whether the system is achieving steady state or other not. Means steady state also in different categories are there. Which kind of steady state it is achieving?
The general average steady state which we mentioned. Average output value at the steady state.
No. The average means it need to be constant, right? DC average, but it is not like that. The average value is there, but is not that is perfect average. We can calculate average, but it's not a exact. It is not maintaining a DC level. This is steady state, I agree, but what kind of steady state that is? See. earlier question for step response, the circuit is stabilizing at 1 volt. 1 volt in the sense at same
uh,
point. After some time,
uh,
this value is constant.
mm,
This is steady state. Now what is happening
steady
was
state.
something
Mm,
stabilizing this point.
mm,
This is steady state. See, this response is
mm.
different, this response is different. So there might be some other name will be there. This is also steady state only. These two are steady states. But when we are seeing the response, that is different. Not a straight line. This is not straight line.
Yes,
But
yes,
these two are
yes,
steady
yes,
states
yes.
only. There might be some other reason will be other name is there for this one. It is achieving steady state, but what steady state? What type of steady state it is achieving?
This
The circuit is
circuit is undergoing some oscillations, and this is some kind of oscillation.
oscillations. Are you sure? These are oscillations.
Yes, sir. Because there is up and to and fro motion is there is some kind of oscillation.
Okay, so can you
Here
justify?
there is no oscillation.
Okay. So this is first one. This is second one. Let us say first one no oscillation, steady state. Second one oscillation, steady state.
Mm.
So you are saying
Yeah,
this is achieving steady state with oscillation. The name is oscillation steady state or what?
some kind of oscillatory.
Okay. The name is okay. Fine. The concept we see. So first point is I am saying these are not oscillations. Can you say why these are oscillations? And what is the main cause of occurring oscillations? Let us say I have one circuit. What is the main reason for occurring oscillations?
Energy transfer. In general circuits, the energy transfer is the main reason. That is the
So
basic.
can you tell here where the energy transfer is happening here?
Here there is this is not exactly energy transfer, but it is some kind of delay-based oscillation.
Delay.
Yeah,
Delay
because it
based
is taking
oscillation.
some yeah,
How?
because it is not reaching to this steady state directly, na, in every case. So like it is taking some time every time, like in every
Means first
case to
one,
reach steady.
let's say first one also I can say delay based response. Means it is also taking some time, right? Huh? Means you are saying oscillations going up and going down. So where is the delay here? I am asking. Here also delay is there. Here also delay is there. At what point you are taking the delay? The statement you are saying is correct. The point is delay. But where you are taking the delay? If I take first one, that is delay. Second one, that is also delay. Then how it is saying delay based oscillations? From zero, some t equal to 0 to some t equal to t. It is taking some time. Okay, that will be fine. Every circuit will take some time, right? So everything will be delay based oscillations only then. Some circuits might get oscillations. The delay is correct only some extent, but with respect to what you were saying, that is a delay.